We have seen the previous concept of circular and green supply chains, and now let's talk about another revolutionary and highly transformative concept known as Industry 4.0. But before we jump there, let's see Industrial Revolution in a quick glance from beginning. Industrial Revolution can be explained in 5 different stages, starting from Industry 1.0 till Industry 5.0. In Industry 1.0, somewhere around late 1700s to early 1800s, focus on mechanization using steam engines and water power was adapted. For example, textile mills used water-powered machines to spin yarn much faster than hand labor. Further in Industry 2.0, around late 1800s to early 1900s, industries introduced mass production with electricity and assembly line concept. For an example, cars like the Ford Model T were produced faster and cheaper using assembly line technology. Further in Industry 3.0, somewhere around mid-1900s, industries brought automation using electronics and computers, where factories implemented programmable logic controllers, PLCs, to automate assembly without human operation at every step. In Industry 4.0, around in 2000s till present, industries emphasized on smart factories with IoT, AI, robotics, and data analytics. For an instance, Amazon uses robotics and AI-powered systems to manage inventory and optimize warehouse operations. Further, in Industry 5.0, which is still emerging, industries are focusing on human-machine collaboration with AI, cobots, and personalized manufacturing. For an example, luxury shoe manufacturers can now combine human creativity with AI-guided machines to produce customized designs efficiently. Now, don't worry with short summary of this revolution. We will talk about Industry 4.0 in detail. Imagine a modern manufacturing plant where machines, robots, and humans seamlessly communicate in real time to optimize production, reduce waste, and meet changing customer demands almost instantly. That's the power of Industry 4.0, and it is transforming supply chains and manufacturing across the globe. Industry 4.0, also called the Fourth Industrial Revolution, emerged in the early 2010s. It builds upon the digitalization introduced in Industry 3.0, but adds connectivity, automation, and advanced analytics to create smart factories and intelligent supply chains. At its core, Industry 4.0 integrates technologies like the Internet of Things, IoT, artificial intelligence, AI, robotics, big data analytics, cloud computing, and cyber-physical systems to make processes more adaptive, autonomous, and data-driven. Now let's understand how this technology works step by step. Our first type is IoT-enabled machines. These devices collect real-time data from production lines, warehouses, and transportation systems. Our next type is AI and predictive analytics, which analyze this data to predict machine maintenance needs, optimize inventory levels, or forecast demand. The third type is cyber-physical systems, where machines, sensors, and humans communicate and respond automatically to changes, such as rerouting a shipment if a delay occurs, or adjusting production speed based on real-time demand. Finally, digital twins are virtual replicas of physical assets or processes that simulate operations and identify potential improvements before implementing them in real life. Industry 4.0 has multiple applications across supply chain and manufacturing domains. In manufacturing, smart factories can optimize production schedules, reduce downtime, and lower energy consumption. In warehousing, automated guided vehicles, robotics, and AI-driven inventory management improve efficiency and reduce errors. In supply chain planning, real-time data from suppliers, logistics partners, and customers enables dynamic adjustments to production, procurement, and distribution strategies. In logistics, IoT-enabled tracking and predictive analytics allow companies to optimize routes, reduce fuel consumption, and improve delivery reliability. A top example of Industry 4.0 in action is Siemens Amberg Electronics Plant in Germany. Before implementing Industry 4.0 technologies, Siemens faced challenges like inefficient production processes, high error rates, and delays in fulfilling orders. Between 2015 and 2017, the company implemented a fully connected digital factory with IoT-enabled machines, predictive maintenance, automated quality inspections, and digital twins for production simulation. The results were remarkable. Siemens reported a 99.99885% production accuracy, a 30% reduction in production cycle times, and significant energy savings across the plant, while also improving flexibility to meet customer-specific demands. So we simply seen that Industry 4.0 is not just about automation. It is about creating an intelligent, connected ecosystem where machines, humans, and data work together to optimize every step of the supply chain. Its applications in manufacturing, warehousing, logistics, and planning bring efficiency, sustainability, and agility to organizations. In a nutshell, Industry 4.0 enables businesses to respond faster, produce smarter, and operate with unprecedented precision, making it a cornerstone of future-ready supply chains. Hopefully, you found this concept insightful, and now you understand why Industry 4.0 is considered a game-changer for global manufacturing and supply chain operations. Now, a very important topic we will talk about next. That's amazing learning I believe you have today, and it's a concept every modern supply chain professional should be familiar with.